Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The strength of ACH bond depends on the percent S character of the hybrid orbital on carbon used to form the bond. A higher S character means the electrons are held closer to the nucleus, S orbitals are closer to the nucleus than p orbitals, resulting in a shorter and stronger bond. Moving on to the next step. Determine the S character of each hybridization. sp hybridized carbon, 50% S character, 1s plus 1p, so a half is equal to 50%. sp2 hybridized carbon, 33.3% S character, 1s plus 2p, so 1/3 33%. sp3 hybridized carbon, 25% S character, 1s plus 3p, so a quarter is equal to 25%. Moving on to the next step. Relate S character to bond strength. Higher S character electrons held closer to nucleus, shorter bond length, stronger CH bond. Therefore, sp 50%, sp2 33%, sp3 25%. And for the final step, confirm with known bond energies. C. sp H bond, example, in acetylene tilde 558 kJ/mol. C. sp2 H bond, example, in ethylene tilde 444 kJ/mol. C. sp3 H bond, example, in ethane tilde 410 kJ/mol. This confirms the order sp to sp3. Eliminate wrong options. B. sp3 to sp, incorrect. This is the reverse of the correct order. C. sp to sp3 sp, incorrect. sp is strongest, not weakest. D. sp to sp3, incorrect. sp should be the strongest, not second. Only option A. sp to sp3 correctly reflects increasing S character leading to increasing bond strength. Therefore, the correct answer is A. Therefore, the correct answer is option A.